Hey guys, 7-2, multiplying and dividing radical expressions. This is going to be the first part, which is just the multiplying part of it. We will do the dividing in the second part. Okay. Multiplying radical expressions. The one thing you must remember when multiplying radical expressions is that they have to have the same root. They don't have to have the same stuff underneath, but they have to have the same root. You cannot multiply a square root times a cube root. It won't work. But you can do a square times a square, a cube times a cube, a fourth times a fourth, right? All right, now let's go ahead and take a look at this down here. Unfortunately, I've not been able to get this fixed. I'm going to rephrase that. I have not remembered to get this fixed. All right, so that should be the cubic root of negative 7, or negative 16, and this would be the cubic root of 4. All right, multiplying these. Taking a look at A, the square root of 3 times the square root of 12. This is going to give us the square root of 36. We know that the square root of 36 is simply 6. Now, going down here, cubic root of negative 16 times cubic root of 4. At first, this might make you a little bit nervous, but because this is a cubic root, an odd root, it is okay to have that negative. So this is going to give us the cubic root of negative 64. When you take the cubic root of negative 64, this is equal to negative 4, right? Hopefully this is what you guys know already. Now let's take a look at C. C is a bit different. Can we take the square root of a negative number and get a real answer? The answer to that question is no. This is not possible, right? Okay, so anytime you have something that just won't work, this part won't work, so therefore you can't multiply them together. If you did, you would have the square root of negative 64, and you can't take the square root of negative 64 and get a real solution, so not possible. All right, moving on to the next example, simplifying radical expressions. Now this is going to be the numbers in addition to the variables, so it definitely does step it up a notch. All right, so you've got 50x to the fifth. The way that I taught this in class, there's two ways of doing this. One is to find factors that are perfect squares and, in fact, the greatest perfect square factor. So this would be 25 times 2, and then x, 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 x. I'll explain that part in a second. All right, we know that the square root of 25 is 5. I have 2 x's, 2 x's. So that means I can pull 2 single x's out. So that becomes 5x squared. And then underneath the radical, we've taken care of this, and we've taken care of those. So we're left with 2x. Okay. Now, this was a method that did not sit well with many of you. So the other way that I showed you was to break it down in prime factorization completely and then pair up or group up pairs in this case, and then remove one of those terms from that pair to the outside. I'll show you. All right, so 50, we know 50, and I would do this part off to the side. Let's see, 50 is 5 times 10. 10 is 5 times 2. So underneath the radical, we have 5 times 5 times 2. And then we have x to the fifth power, so 1, 2, 3, 4, 5. All right, now I go through, and because this is the square root, I'm going to find pairs, groups of 2. So 2 5s, 2 x's, 2 x's. Now, with the pairs, I just bring one of them outside. They come together. You merge them together, if you will. So we're going to have a 5 out front, an x out front, and an x out front. And then underneath the radical, we have 2 times x. So on the outside, we have 5x squared, square root of 2x. Same exact answer as this one over here. It's just a slightly different approach to getting it. Okay, let's go ahead and take a look at B. Didn't mean for it to move up that far. Cubic root of 54 into the 8th. Now, because this one tended to be a better received method, I am going to use that prime factorization. I know 54, I'm going to do the work right here, is the same as 6 times 9. This is 3 times 2, and this one is 3 times 3. I can't break anything else down, so now I'm going to go ahead and put it underneath the radical. So we've got, I'm going to put all the 3's together, 3, 3, 3 times 2, and then I have 8 ends, so 1, 2, 3, 4, 5, 6, 7, 8. Almost made that one an M. All right, now because this is the cubic root, we want to find groups of 3. So we've got 3 3's, we have 3 ends, 3 ends, and then we would have those 2 left over. So we're going to pull a 3 out, an n out, and the other n out. So outside, we have 3 times n times n. Inside the radical, or underneath the radical, we have 2 times n times n. So on the outside, simplifying this, 3n squared, cubic root of 2n squared. And that's it, all right? Hopefully that explanation is good for you. Let's go ahead and take a look at the final example that we're going to go over on this part. Multiplying radical expressions. So now we have the big boys, bringing out the big guns, right? Let me scroll this up just a, oops, I don't want to, there we go. All right, we want to multiply and simplify if possible, assume all variables are positive. Therefore, we don't have to think about any restrictions, any absolute values. We don't have to worry about any of that. All right, so we want to multiply these 2 guys together. What I have found that works the best is if it's not something I know immediately, and there's a lot going on here. So I would just do 25 is the same as 5 times 5. So we're going to have 5 times 5 times 5. So now we've taken care of this, and we've taken care of that. There's an x, 1 x on the left. There are 4 on the right side, 4. And then there's 8 y's, 1, 2, 3, 4, 5, 6, 7, 8. And then there's 3 over here, 1, 2, 3. All right, seems a bit excessive, but it does get the job done. Okay, now because we are finding the cubic root, we are looking for groups of 3. So we've got 3 5's, we have 3 x's, we have 3 y's, 3 y's, another group of 3 y's, and then that's all we have that we can group up. So now we bring this 5 out, we bring this x out, we bring all of these y's out, and so outside we now have 5 times x times 1, 2, 3 y's. 1, 2, 3. Cubic root, this is gone, whoops, and these are gone. So now we have x times x times y times y. All right, so on the outside, 5xy cubed, and then the cubic root of x squared, y squared. And that is your answer. There's nothing else you can do with this. Again, hopefully this helps. If not, you know where to find me.